Today, we are moving beyond traditional cryptography to explore the eidophonic approach, a framework that treats this ancient text as a complex acoustic record. Our conceptual foundation is built on the realization that the manuscript may not be a simple alphabetic cipher. Instead, we are looking at a system where visual forms represent vibrational states. Notice the emphasis on harmonic encoding. We are analyzing these glyphs as a frequency-based language system, where the relationship between characters mirrors the intervals of a diatonic scale, potentially mapping out specific Hertz values. Moving to the research and validation phase, it's crucial to understand that this theory isn't just a shot in the dark. It is grounded in rigorous pattern matching and cymatic simulation. The pseudoscorponation methodology, pioneered by Amber Dorothy Gaxiola, has demonstrated remarkable consistency across 102 folios. This suggests that the eidophonic logic remains stable throughout the entire document, which is what we'll be dissecting in the coming sessions. Eidophonic logic we just covered, let's look at the actual mechanics of the decoding pipeline. This is the workflow used to translate a static image into functional linguistic meaning. The process begins with the visual glyph. In this system, every stroke and curve is treated as a set of acoustic instructions. That glyph corresponds to a specific frequency measured in Hertz. When we apply that frequency to matter, we get the cymatic pattern you see here. This brings us to a key concept, the physicality of sound. We aren't just dealing with abstract symbols, we're observing geometric resonance, where sound physically organizes matter. However, to get the full meaning, we must account for contextual systems like herbal or biological layers. This informs how the syllable is ultimately interpreted. Finally, all of this rests on the universal base layer, the fundamental vibrational logic that remains constant. Understanding this pipeline is crucial before we move on to simulating these patterns ourselves. Building on our discussion of frequency precision, let's examine how these values are categorized. This is the 3-5 glyph key structure, the organizational map for the entire decoding process. At the very base, we have the infrasonic foundation. It utilizes the gallows glyphs, specifically F, P, and T, to establish base frequency stabilization. These are the deep, structural roots of the system. Think of these as the anchor points. Without stabilizing the infrasonic layer, the higher frequency patterns would lack geometric clarity. Moving into the audible spectrum, we find diatonic scales 1 through 3. This range, primarily C4 to B4, is where we integrate the harmonic series, allowing the glyphs to represent recognizable musical structures. As we climb higher, we reach the microtonal benches and the ultrasonic boundary. Glyphs like G and X map frequencies that often sit right on the edge of human perception, handling the boundary mapping. Wait, so we're going from subwoofer vibes to dog whistles? This keyboard is getting intense. It is intense, but precise. Finally, notice the meta-acoustic glyphs V, U, Z, and G. These are unique because they don't encode Hertz at all. Instead, they represent non-Hertz's properties like timbre or density, giving the system its qualitative depth. Now, let's look closer at scale 1. Building directly on the decoding stability we established on the previous page, let's now examine the diatonic scale's core mappings. This is where our theoretical framework meets empirical acoustic data in the C4 to B4 range. In this table, you'll find the precise frequency assignments for our primary single glyphs. For instance, notice the glyph Q at 261.63 Hz and Y at 329.63 Hz. These aren't arbitrary values. They are the foundational nodes for our cymatic pattern simulations. Beyond the technical frequencies, each mapping carries a specific semantic directive concepts like grow, mix, renew, and flow. In the eidophonic approach, the resonance frequency itself encodes the underlying meaning of the glyph. Finally, focus on the role of the separator glyph, represented here by the period. At 493.88 Hz, It acts as the primary syntax for our sequences. Without this separator, the universal context of the mapping would lose its structural integrity. Ensure you have these mappings committed to memory, or at least highlighted in your notes. They are the constants we will rely on as we transition into harmonics and critical corrections in the next section. Building on the constants we just covered in the previous section, we now move into harmonics and critical corrections. This stage of the pipeline is vital for stabilizing the translation against semantic drift. Let's examine the diatonic scale too. Here, we transition from primary glyphs to digraph harmonics, where two distinct elements combine to create a specific resonant meaning. Take the sh digraph, which identifies as sky in our cymatic mapping, and I, which resonates with life. These pairs act as harmonic anchors within the larger diatonic structure. Next, we have the locked corrections. These are fixed mappings that have been recently finalized. For instance, notice the all to oil and R to above correlations. These corrections are non-negotiable within the current decoding framework. A crucial aspect of our methodology is the contextual shift. In this example, the all translation shifts specifically to root system when toggling between herbal and biological datasets. It demonstrates how the master key adapts to the domain of the inquiry. Finally, please note the master key lock date of the 18th of October 2025. This date is our temporal benchmark. Any data decoded before this point may require reprocessing through these new critical corrections to ensure harmonic accuracy. Building directly on the harmonic corrections we just established, we now move into the functional layer of the glyph system, the meta-acoustic and boundary glyphs. These elements are essential because they control the how of the sound, its texture and limits, rather than just the what of the pitch. First, let's examine the 9 meta-acoustics. These glyphs, ranging from V and U to Mi and L, act as the primary modifiers for the sonic envelope. As you can see here, they encode the sustain, attack, and modulation characteristics. In our cymatic simulations, these glyphs determine how the vibrations bloom and fade, giving the sound its unique timbral signature without shifting the fundamental frequency. Next, we have a very specific set called the gallows, comprising F, P, and T. These function as subaudible structural anchors for sonic framing. They don't produce a tone we can hear in the traditional sense. Instead, they provide the necessary tension to hold the audible frequencies in a stable formation. Moving to the edges of our spectrum, the boundary glyphs G and X define the ultrasonic ceiling. These are critical for mapping the frequency limits of the eidophonic field, ensuring the data doesn't bleed into chaotic noise at higher registers. I want to emphasize the technical note at the bottom. Meta-acoustics modify timbre without changing pitch. This distinction is the key to mastering the 3/5 glyph key structure. Now, considering the invisible nature of the gallows glyphs, how might their absence affect the physical stability of a cymatic pattern? Building on our look at cymatic stability, we need to move beyond the glyphs themselves and look at their precise positioning. This is where the phi coordinate methodology becomes essential for our research. By applying spatial coordinate analysis specifically to folio 85, we've identified structural relationships that remain invisible to traditional linguistics. We aren't just reading symbols. We are mapping a physical field where the where is just as important as the what. At the heart of this spatial field is the governing ratio, represented by the Greek letter phi. In this framework, phi acts as the underlying mathematical constant that dictates how glyphs cluster together. The formula you see here, the golden ratio, provides the mathematical validation for our decoding framework. It moves our study from subjective visual interpretation into the realm of objective geometry. This non-linguistic approach suggests that the parchment was designed as a calculated diagram rather than a standard text. It allows us to bridge the gap between spatial data and the harmonic frequencies we just discussed. Welcome to the Lingua Now that we've seen how the decoding workflow produces a linguistic output, we must address the why behind these patterns. This brings us to the HSG connection, situating our research within the broader harmonic substrate gravity framework. The Lingua module we have utilized is essentially a linguistic application of the HSG framework. It treats phonetics as dynamic frequencies, suggesting that the structures we find in the Voynich Manuscript aren't just arbitrary symbols, but are governed by the same laws as physical matter. This leads us to a fundamental universal principle: frequency as an organizing force. If the universe is built on harmonic resonance, then a sufficiently advanced language system would naturally align with these geometric constants. This isn't just theoretical philosophy. The HSG framework makes concrete predictions, specifically regarding the dark energy equation. Look at this formula: W equals -1/phi. It's a profound moment where the phi geometric principles we use to map the Voynich glyphs on page 9 intersect with cosmological constants. We are looking at a single mathematical language describing both the micro and the macro. Moving directly from our exploration to a close, let's discuss the provenance of this decoding system and where the research is headed next. Building on the technical workflows we just covered, it's important to understand the formal framework surrounding this discovery. First, for those interested in academic priority and formal records, the system is officially registered under copyright TXU 2507227. This ensures the integrity and traceability of the methodology we've analyzed throughout this session. For practitioners, please note that the master key PDF is the essential reference for the microtonal and trigraph values. While we've discussed the core theory, that document contains the specific frequency mappings required for high-fidelity reconstruction. Looking ahead, the Lingua hypothesis represents our most exciting frontier. It suggests that the acoustic resonance principles we've applied to these glyphs could be scaled to other undeciphered scripts, potentially bridging the gap between cymatics and historical linguistics. For further reading, Quantum Blueprint and Extraterrestrial Harmonics provide the broader theoretical context for this work. It has been a pleasure guiding you through the decoding pipeline today. Remember, the key to understanding these ancient patterns lies in the intersection of geometry and sound.